A permutation formula, and here's some notation for you. N is the number of people, objects in the group. R is the number of objects from that group that I'm going to arrange. Okay, so this is the notation NPR, or it could be written as P parentheses N comma R. And so the expression here at the end is what I just talked about. We're going to take n factorial divided by n minus r factorial. Now, it's not completely necessary that you know this formula because your calculator will do permutations for you. It's actually in that same menu. If you go to Math, Probability, number 2 is a permutation, and you see the notation NPR right there. So the calculator will do it for you. I could take 8 and permutate 3. That was what we just did in the previous example. We're taking 8 racers and seeing how many ways we can arrange 3 of them for the top 3. And if I put this in my calculator, and if you have the newer calculator, it just gives you boxes to fill in. If you have an older one, you have to type 8 in first, then go to NPR, then type in the 3. But it came out to 336, which is exactly what we got in the previous example. All right, so now we are on to example 3. 12 skiers are competing in the final round of the Olympics, freestyle skiing aerial competition. How many ways can 3 of the skiers finish first, second, and third to win gold, silver, and bronze medals? Same idea, except this time we have 12 people to choose from, and we're arranging 3 of them. So we're going to use the calculator. Since I just put this in the calculator with an 8 there, I'm going to hit second enter, which just brings up the previous problem, and I'm going to put a 12 in the box where the 8 was, and that jumps it up quite a bit. So we have 1,320 different ways that 12 skiers could come in first, second, and third. It's kind of crazy how many there are. Let's do another example. This one's a little bit more fun. How many different ways can the letters in the word classes be arranged to create 7-letter words? Words are in quotations here because they don't have to be real words. We just want them to be different words. Okay? So unique arrangements of these letters. So here's what you have to be aware of. When we're talking about a word like classes, we have 3 S's in this word. Now, if I switch this S with this S, is that a different word? No, it's still the word classes. And so because we have 3 S's, we need to make sure we divide out the number of ways that you can arrange those 3 S's, because they're repeats. We don't want that to be factored in there. So we're going to take the 7 letters in the word, and we're just going to arrange them 7 factorial. The reason we're doing this is there's 7 different letters that I could use for the first letter. Once I've used that letter, there's only 6 letters left, and then 5, and then 4, and then 3, and then 2, and then 1. However, I want to divide out the repeats. So how many different ways can I arrange 3 letters? Well, that's easy enough. There's 3 S's, and we talked about this already. If I have 3 people in the Olympics, in the finals, this was the warm-up. I had the US, Russia, and China. If I have those 3 people, how many different ways can I arrange that? The answer was 6, and that came from 3 times 2 times 1. One of the 3 teams is going to come in first, and there's only 2 teams left over for second and 1 for bronze. And so I'm going to divide by 3 factorial. And this 3 is because this is the number of repeated S's. Okay? So if all the letters in classes were different letters, then the answer would just be 7 factorial. But because S is repeated 3 times, I need to divide by that. Otherwise, I'm going to be, let's call this S1 and S2 and S3. I can have classes with a 2, 1, 3. I could have classes with a 1, 2, 3. I could have classes with a 3, 2, 1. I could have classes. I think you get the idea. There's 6 different ways that I could write the word classes, just arranging the S's in different spots. But those aren't different words. They're not unique words. And so that's why I'm dividing by 3 factorial. And so if I do this out, 7 factorial, basically dividing by 3 factorial means I'm canceling out these. And so my actual answer is 7 times 6 times 5 times 4, which is 840 different words, different unique arrangements of those letters. So let's do one more example, just sort of like the one we just had, except now we're talking about the word Mississippi. So Mississippi has 1 M, 4 I's, 4 S's, and 2 P's. If the letters are randomly arranged in order, what is the probability that the arrangement spells the word Mississippi? So now we're talking about a probability. And when we talk about a probability, the denominator is always all of the different ways we could do this. So we want to know all the different ways we can arrange the letters in the word Mississippi. Well, there are how many letters in Mississippi? So it's Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 letters. However, there are 4 I's. So I want to make sure I divide out all the different ways I could arrange the I's. There's also 4 S's. So I want to divide out all the different ways that I can arrange 4 different S's. And there's 2 P's. So I want to divide out all the different ways I could switch the P's around. Now this number in the denominator is the total number of ways that I can rearrange the letters in Mississippi and get distinct words. So let me calculate this. So I'm going to math probability. Number 4 is going to give me the factorial. So 11 factorial is a huge number. It's actually 39 million, almost 40 million. Okay. And then 4 factorial. 4 times 3 is 12, times 2 is 24. So this is divided by 24, divided by another 24, divided by 2. So I'm going to take that number divided by 4, divided by 4, divided by 2. Sorry, not dividing. So that's going to give me, the denominator here is 34,650. Okay? Now, out of all of those words, how many are the word Mississippi? Well, since I took out all the duplicates, like where these 2 were switched and these 2 were switched, since I took out all the duplicate Mississippis, there's only one way to make the word Mississippi. So the answer here is 1 out of 34,650, or 2.89 times 10 to the negative 5. So that's 0.0000289. So it's basically a 0% chance it's going to happen, but it could happen.